This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST Robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
There, can you hear me?
Yep.
Yes, sir.
Had it muted. Okay, we have a fun new feature in Google Meet. Apparently, I can only be signed in with one account one time. I can't use the same account twice. So,
Sounds about right.
jumped around a little bit. I've recorded it that way every time, and suddenly it doesn't work. Anyway, welcome everybody. Tonight's call is going to be hosted by WildCards out of Mounds View High School, 3407, right? All right, excellent. And you guys are going to be talking about outreach robots. And I don't have anything to add to that. I'll let you guys introduce your topic. Also, I want to mention that this is going to be our last call until the fall. So we tried to do this in the summer last year, and it just got to be too hard to figure out what Sunday is the Sunday we're doing, and attendance was low. So we're not going to try to do any calls this summer. We'll resume in probably September, I think, is probably when we'll pick things back up. But this will be our final call until we're back in school in the fall. So with that, WildCards, the floor is yours. Take it away.
Outreach robots, yippee! Okay, hello. We are 3407, the WildCards, and we are here to present on our journey so far on making and doing outreach.
That's David. I'm Isaiah. Shrikar is also here. Lisa's our mentor. I think all of us except Lisa are programmers. So there you go.
So why would a team do outreach? And there are a couple of reasons. It can serve people that are outside of robotics for entertainment, or perhaps even getting them seriously into robotics so that way they can join and greatly benefit our team. And it gives all of us who are already on the team something to do while we're not in season working on our main competition robot, and it's really fun. There are many benefits to building an outreach robot. It teaches everyone on the team technical skills like designing and building things that are reasonable in a bunch of different scenarios. There's a lot of documentation that comes into play when trying to get feedback and making things better and continuously getting good communication. Troubleshooting is a huge thing that comes in. You have to, actually, pretty much most times while you are at an outreach event, end up troubleshooting the robot because something will inevitably go wrong somewhere. It helps a lot the kids with presentation skills. Presentation is probably not something that people who like building robots are super great at. And so being able to teach that skill to these people is great. And it also teaches you how to interact with people from many, many different backgrounds, of many different ages, with varying abilities. And of course, it shows what our team does over the season. It shows what it means to build a robot, what a robot actually is to everyone. And it's super fun. And it's great to see everyone excited about something that you created, because they just don't know as much of the process. And it's often times like you undervalue yourself when doing these things, and then when you show it to other people, they see the value, and it's awesome. And it entertains them all, and it greatly educates many audiences. So there have been a few different outreach robots we've used over the years. There's a t-shirt cannon, which just has four air powered cannons. It shoots t-shirts, and it's super fun. We use it a lot at the school pep fest. We can shoot the Mounds View merchandise into the audience, and it's great. And reused a lot of our competition robots for this, because the competition robots are often very robust and really awesome looking. But there are some limitations that often come into play when we build these robots and are hard to deal with. Competition robots, oftentimes, when they haven't been used for a while, they haven't been edited for a while, things have slowly gone into disrepair. Maybe people have taken the parts off of the robot so that they can use it for another competition, and it ends up not being as robust. It ends up being way heavier than you would want it in a outreach. And there's a lot that competition robots often do, which leads to very complicated controls. And competition robots are very good at throwing things very far. And when you only have like a 10 by 10-foot square to work in, that's not very good. And they can be big and bulky, which makes them hard to transport. You need a big truck to be able to get them from place to place, or even a trailer. Um, and a lot of the time, the program that is used during competition makes the robot go way too fast or do dangerous things that you wouldn't want up and close to, say, small children. So we thought we'd need a dedicated robot. There are a lot of specifications that we wanted for this dedicated robot. We wanted it to just reach basic FRC standards, so we're not putting like a big leaf blower on it or anything. Um, but it doesn't have to be legal. There are fun things that you can put on an outreach robot, like big speakers that you would not use in a competition. We want it to be small and light for easier transportation and less damage if you crash into something. We want it to be robust because it's going to be used by many people of different skill levels, and they're not always going to do what you expect them to do and end up destroying things. But if it's able to take this damage, then it's much better. And we want to use features that will make it engaging and fun for as many different people as we can. whether that be making it so it can interact with a lot of people at a time, or being simple and easy to interact with. Um, there for some outreaches we might have people who are not very experienced with robots actually driving the robot, because it is so fun to just drive a robot around, which means that we need to make sure it's not going a million miles per hour, and it doesn't have big hammers that can just smash everything in a room, and it needs to be easy to figure out the controls and be able to do them. We want to make sure that they can be used inside of a classroom, because like I said, we can have only like a 10 by 10 foot space, and there are things that you just can't do inside of that little space. So to build this robot, we actually ended up getting a grant that was specifically for getting outreach to anyone. And we use this grant to begin building a feasibility robot to put just like all of our ideas into, and just see what we can do to try and fit this criteria as best as we can, make it super fun and able to be used by anyone. So on this feasibility robot, we have a few pretty cool features that we are going to take turns talking about. We're going to start with Isaiah's presentation of the wireless controller. We have a video of him using a Wii Fit balance board to control a little game he made on his computer. Isaiah, if you want to talk about it more while the video is playing, that would be great.
Oh, yep. So yeah, the red dot in the middle is like your center of balance. Sort of, it averages out the weight of the four sensors. We this was like a proof of concept just to see if it would work and be robust enough to work as a controller for the robot, which I think it did. I haven't written a subsystem yet for it, but I originally I'm unmuted. Good. Okay. I don't remember exactly how it is, and David, you can correct me, I guess, or anyone. But Calvin, another team member, brought in his Wii balance board. Just I forget what his reasoning. I forget why, but just so we could see if it would work as a controller. And I spent the next week finding a few libraries for interfacing with Wii remotes and the like. One of which, the only Java one that I could find, was like 11 years old, and it had weird circular dependencies that or outdated stuff that I couldn't. I had a bit of trouble with, but I found a C library that works, and that's what I wrote the demo in, was just C. So yeah, I think that it should be fun and easier for kids to or other people who are not on our team to figure out the control scheme of once we have that as a controller. You just lean forward and the robot goes forward. It's that simple. I don't know. I think that's pretty cool. That's about all I have to say for that. Yeah. There you go. Wii balance boards are cool.
Yeah, that would be a super fun challenge for anyone who like to try. So, to make the robot super fun and just great to look at, we decided to add these fun, wacky, wavy, inflatable arm flailing tube men onto the top of it because they are big, great, and just super fun. And on this video, it zooms into the on-off switch because we couldn't get it to work for a super long time. And then we found out that it was switched off. And then it worked instantly. And that was great. So we're planning on using this as some sort of signal for when things are happening, for when things are starting, in just like a really fun and interactive way. We also started creating lights for the robot, so that way there is a visual aspect to signals. And Shrikar, would you like to talk more about those?
Yeah, so we have like LED light strips that are individually addressable, or like shown in this video, a block of them shares one address, I guess. And we use a microcontroller, either a Pi Pico or like an Adafruit Feather, I think, to control them using CircuitPython. And basically you can set a timeout for like every however many seconds, send whatever code you want to the lights. So we made a couple programs. We have we have text. And we also have like some other programs that might be useful more in competition rather than outreach. Like blinking and flashing red, white, whatever. And yeah, I think that's pretty much it.
Yep. Lights are a great way to signal whenever something specific is happening. For our outreach, we're going to have the robot write text for commands that we're running. This will be useful for something that I will show you in a bit. But right now, we're going to talk about sounds. Isaiah, would
yes.
you like to talk about these?
I would love to. So, we'll let this play. This is after 3 hours of hard, grueling work, trying every single way to get sounds to play from the Pi. Trying every single audio device. I realized that I had to install drivers. Not sure why I didn't think of that earlier, but it worked instantly when I did that. So there you go. Speaking of ways to signal when something important is happening, yeah, sounds are another great way to do that. I think right now we have, I don't even know. I forget what sounds we have on the robot, but yeah, they'll be fun.
Yeah, so the sounds we have on the robot right now are just like cartoony noises, cartoony slipping sounds or screams or stuff like that. And we are soon going to add my voice actually doing my
Oh,
robotic
yeah.
voice, saying the commands that it is currently operating. As like another way on top of the text on the lights to signal what's going on. So that way, if someone is deaf, they can look at the lights, or if someone is blind, they can hear the sound and they can know that the robot is doing what they told it to, and it's just awesome. And that brings us to these whole commands thing that I was talking about before. So I am going to take it away in this video.
I don't believe you're sharing the audio from that screen share, David.
There is no audio. Okay. Let's get captions on then. Or see if I can fix the audio. Probably not. Yeah. Okay. Captions. Here we go.
Wonderful.
Super cool. In case you didn't see, the wheels went off for about 1 second right at the end of that whole program. So the way that it works is it creates a list of all the different tags that you've shown it. So to start creating that list, you show it tag number 5, which is the initialize program tag. And then in order to add each command, you show it tag number 11, which is the next command tag, and then whatever tag correlates to what command you want it to do. And then once you have shown it 11, and then tag, then 11, then a tag enough times, and you have a full program that you want to execute, show it tag number like 35, and the whole program will execute. And we have a bunch of different commands right at the moment. So we're thinking that every single different command you can do will have its associated lights, which will show big text that is whatever command you're showing it, and then a small text that will show the number of commands that are currently in the list. And then we will also have sounds, my robotic voice, telling you every command that the robot sees. The various different commands we have is activating the wacky wavy inflatable arm flailing tube people, move forward, backward, turn left or right, spin left or right. And that is about it for now. And actually, here would be our first possible chip in from the audience. Do you guys have any possible ideas for commands we can do with our current outreach robot?
David, do you have a target for your kind of the first audience you're going to take this to?
Not at the moment. I think. What is the first outreach that we do each year, Lisa?
Generally, it's the Pep Fest. We have taken this robot we have taken features of this robot to a couple of different places. One of them is we have what's called a reflect period every Wednesday in the morning. So we have taken it to one crew. We've discussed it with our special ed folks at the school. We've discussed it with our teacher of how to make almost everything at the school, who also has worked with some accommodations for folks with special educational needs and physical disabilities. So right now we don't have all the components together on one base to have everything integrated together. We're close, but we've got most of the features implemented on separate platforms. So once we get that together, I'm not really sure. I think Reflect is the best place for us to bring it out because it gives us an ability to target small groups and get more feedback and try it in a smaller area, a bigger area, see what works best.
Okay, so Reflect would be high school students anywhere from grade 9 to 12 with any possible physical disabilities, because it could be just anyone from the school.
Okay, good. So my first reaction was this would be awesome in a small group scenario. We do things with the Girl Scouts often, and I feel like this would be a great project type day with the Girl Scouts, especially if your goal is to let the participants sort of build the program with your April tags. I feel like that's really a small audience experience. I don't know how this would work in the Pep Fest. Do you have ideas of how you would put this in front of basically the whole school and make it engaging to the point where I don't know how much time you guys typically get for Pep Fest, but I'm imagining it's not very long.
Oh, yeah, no. Our first outreach is typically the Pep Fest. I don't think it's a good venue for this robot.
Yeah. Okay.
That's usually a t-shirt cannon thing, and it's
Yeah.
there's no intro to robotics. There's no other people can drive it. We don't talk about it. We go, we shoot t-shirts, we're done. So
Sure.
this one, I think it's flexible enough that in a small group, you could get very in-depth in a couple of features, and in a larger group, you could just drive it and use some mechanical ball handling, and that's the interaction that you want.
Yep. Yeah, I think this platform sounds like a platform where you've got a fair bit of flexibility. With the balance board thing, that actually could work really well in sort of a parent-teacher conference night at a middle school or an elementary school, where kids get in a line and they take turns standing on the board and making the robot drive around. And I think that's a great sort of experience in that scenario. And then small groups like you're talking about with the Reflect group, or as I was mentioning, the Girl Scouts, where you've got maybe 3, 5, maybe 8 to 10 students who are working on trying to navigate the robot through a set of cones or a maze, and then play the lights and the music when it gets to the end. I feel like those are really good situations. You mentioned blind students. Do you have blind students that you've worked with, or that you already have in mind to bring this robot to?
Not that I'm immediately aware of.
Okay, because
Um,
I'm actually advising a student group who are building an educational platform. It's a school project, but it may actually end up turning into a venture. And their target is students with either low visibility or no visibility. And one of the things that I brought up to them was you need to have some kind of tactile touch with the robot. So being able to have antennas or something stick up that you can get your hand on to sort of tell that the robot's moving and follow it could be really important for those scenarios. But if that's not an audience you've already identified, it's a really hard audience to do stuff with robots. And so hearing impaired, and then along with all the other folks that you've already mentioned, maybe a better group for what the platform you've already put together. Your question is what else would the robot want to do? I don't know. I like the balance board. That's very creative. Um, can you control it with just a joystick as well?
Yep.
Yeah. Okay. Something that could be fun is that if you can get your hand on an old Xbox Connect and you can find drivers, which I think Windows 95 or Windows XP was the last time they made drivers for those things. But doing motion and making the robot drive based on your hand movements, that could be a lot of fun for students and very interesting programming challenge. I have zero advice on how you would go about doing that, but that could be something fun as well.
I am looking up libraries for that right now. That sounds really fun.
I will tell you that I did do a little bit of research on the Xbox 360, and I think that's pretty much almost a completely lost cause because drivers are so old and out of date. The Xbox One, however, it may be possible to find current drivers. They did make a developer harness, so you can connect that to a PC. You can usually find an Xbox One visual head in pawn shops or secondhand stores for an okay amount of money, but the developer harness will cost you probably more than what you'll pay for, a pawn shop or well, if you find one at Goodwill or Salvation Army, you'll probably get a heck of a steal on it. But if you're going to a pawn shop, it'll probably be like 30 or 50 or maybe even $75. And I think that harness might be pushing up to 75 to 100. So it could be kind of pricey. But that could be really neat too. I've thought about trying to control robots with human movement, and it might actually even be better to find a camera on Amazon and an open source library that can just use a normal webcam and pick up human movements. But that could be really fun.
That's true, but it'd be fun to do it with the Kinect.
It would be fun to do with Kinect. However, you also want to pick a platform that you have confidence that is, something that you could do a demo and then say, hey, you could do this too, or try to, teach other robotics teams. That's great for things like the Impact Award or the Engineering Inspiration Award, if you can inspire other teams to take on your project and replicate what you've done. So we always, when I try to encourage kids to come up with projects, I try to encourage us to do it in a way that if it actually worked and it was successful, that we could teach other teams how to do it too. So that's my advice in that area. I've done a lot of talking. Does anybody else have any thoughts on outreach robots, this platform, or maybe just any platform in general?
Well, David, why don't you go to your next slide and talk about some of the things that we have learned by introducing robots in outreaches to different groups?
Okay. I actually kind of thought of an idea on how to do what Scott was talking about, because we can get the position and direction of April tags if we can just put April tag in each hand, and then it can easily detect the movement of that. Um, do we have any pressing issues with features we currently have implemented? It looks like no, and I don't have any in mind. So here's what we've learned from the different outreaches we've been to. A lot for one of our outreaches, we went to a elementary school, and it was engineering night, and was basically just an event where a bunch of kids get to go and learn about engineering. And for that, we allowed any child to go up and start controlling the robot. And probably what we learned from that is we can't teach someone all of the controls all at once. They'll get overwhelmed and end up doing something crazy or unexpected. So it's always a good idea to start with the simplest of pressing a button to make it do something, and then teaching them how to let the robot move around, and then teaching them how to let the robot move around and press the button that does something. For younger or less focused audiences, there are some changes that we figured that is best to make. It's better to have smaller rooms, because with a big, huge space, there's a lot of room to get distracted. If you're in this big area, you'll like run out to the middle of the big area, and then you're away from all the action, and you're like, oh. So it's better for a smaller room. Smaller groups, they're easier to control, and it's much easier to get everyone to do everything that we want them to do with the smaller group. Um, Driving kind of close to the audience really gets them excited, um, because they get to see the robot working its everything really nice and close. And also the robot it's kind of scary. It's big and loud, and it's like, whoa, which makes it very exciting. Um, more storytelling is always great. Um, while we were at that engineering night when we had kids driving the robot, sometimes the rings we were using in this past season's competition robot, sometimes the rings would just rip open, and then the kid would get sad because they broke the ring. So one of our team members ended up coming up with this thing that's like, our robot has an addiction to eating rings. 'Cause that's what it was doing. Um, and that made it easier and more fun for people who ended up accidentally breaking the rings. Um, for people with autism spectrum disorder, we found that it is better to work on small, simple, specific things to work on, like just pressing the button, making something fling, just driving around, things like that. And oh, we've also learned that help from outside would be really nice. Getting a sign language interpreter would be great, so that way we can just do our thing, and people who are deaf will be able to follow along the entire time. Having wheelchair accessibility will be nice. Um, Currently, we kind of just have one stand for our drive station, and it's kind of high up, and you kind of have to stand. So we could probably get something to help deal with that. Um, Extra teachers and parents for students who need more direct attention is always nice. Um, we need to be proactive as well. We want the audience to always be doing something, because if they stop doing something, then they end up just like not really getting as into it and not really wanting to continue. So we want to give the audience as many specific acceptable interactions as possible, so that we all understand um, what the robot will do up front. I think is what those were. And give the programmers guides for what will happen during outreach, and always be ready to e-stop, because robots and people you don't know are both very unpredictable. When things go down, you gotta be ready. Um, Here is a lot of the outreaches we have done so far. Um, there was a Science Olympiad competition at our school, so we took the robot out and started having the elementary school kids just shoot rings. I would drive the robot to pick up a ring and bring it facing the right direction, and then we'd let them just push a button, make it go, and it was super fun. People went out and caught the rings, and it was really fun. We did one during Reflect, which is um, something that our school does to give people extra time to do what they need during school. It's at the morning on Wednesdays, and the special ed class came in during uh, one of the times we did that. So that gave us some insight on what to expect there. We've gone to elementary school a couple times. First for the engineering night, where we allowed anyone to just drive the robot and showed off its features, and it was great. And then we did a third grade class presentation. There were 3 sets of like 3 classes each, all watching a presentation that we repeated. And in that, we used like April tags to do a magic trick, and we showed off how the robot drives and flings rings and autonomous. commands. We did the 8th grade activity fair, which I don't think I was a part of, so I don't know what happened there. Lisa, could you, or if Shrikar or Isaiah were there, could you explain that?
In general, at those fairs, our robot is not running. That's more just recruiting potential new members of the team. So we can take any robot. We like to talk about it. Sometimes we'll have a video playing to kind of describe what the game is like. But generally, it's kind of a zoo with a lot of 8th graders, sometimes parents, a lot of kids milling around at different activities.
Okay, and there's also the Pep Fest, which we take the t-shirt cannon to, and we drive it around in front of the audience and shoot out Mounds View merchandise into the audience, and it's pretty great. I have a couple videos of the Science Olympiad. We're just going to play this one. Me showing off the how the robot drives, picks up rings, and shoots to the 5th graders in the beginning of the outreach to basically start up and gain some engagement from them while they're on their break. And it's really fun. We were talking to the kids, telling them the process on how we built the robot, how long it took, what the batteries are like, things like that. And as you can see there, the kids were getting their hands on the rings and passing them back to the robot from time, and that was really fun. I think they're right off the edge of the screen here. There's actually a second floor that the robot is kind of shooting towards, and eventually people ended up going up there, and a couple people actually managed to catch rings that were flung from the bottom floor to the second floor. And I think right at the end of the video, I lost control of the robot and it started moving forward for no reason. And that was a little odd, but we managed to e-stop it. So that was great. So that brings us back to ideas from you. What do you guys do for outreach? What robot features do you have to make outreach happens? And what ideas do you think would be helpful for us?
I have a question about your robot that I failed to ask before. Are you using the RoboRio for this outreach robot or using a Pi?
The RoboRio, but a Pi is what runs the vision and the sound.
Okay. And so do you imagine that is your RoboRio mounted on the robot in such a way that you could take it off to build a practice bot or a competition bot or have it as a backup RoboRio, or is it sort of buried? Is your goal to always have that RoboRio on your outreach bot?
Our original goal was to use an alternative control system. And when we were looking into it, to do the feasibility for the different features, we decided to just go with the tried and true RoboRio. We know what we're working with.
Mm-hmm.
We've talked about having kind of a Borg cube, we call it, which is just the control system on a removable modular platform that we could use on a test bot, we could use on the outreach bot. It makes an outreach bot really expensive to have all those controls on it. So if you have ideas on that, that would be wonderful. I know, for example, the Romy robot is piggybacking a Raspberry Pi on a controller that
Yeah.
allows that controller to use the FRC libraries. But I
It-
don't know if we can get that to talk to the motor controllers, or if we would need a standard PDP, what we would need to do that. Most of what we saw for alternate controllers or control systems were FTC kind of sizes.
Yeah. We have 5 Rami robots platforms. We bought just the control board and we 3D printed our own bases and wheels. Last summer I spent a lot of time because I was trying to see if I could come up with a way to build a platform as a training platform for our programming students, and I was trying to build a baseline for that so that our veteran students could then continue that work through the fall and try to work as a side project in the fall, since they don't need to do training. The idea would be that they would build training, so the stage 2 or stage 3 type training using the Ramis. So I spent a lot of time on it, and I have to say I walked away from the Rami very disappointed. And I've done a little research on the XRP, which is the new platform everyone's talking about. Very similar limitations. I will say that if you want to try to use the Rami to control your demo bot, you have 5 outputs that can either be PWM or servos. The PWM that it kicks out is the same PWM signal. I think it's called a interlocking phase signal. I'm sure I'm getting that wrong. Ben's on here. Ben, he found it. He told me, so he might be able to find it again, look it up. But what it does is it breaks the PWM signal from 0 to running full speed. It breaks it half, so that when you're at the bottom half, you're driving backwards at full speed. When you're at the top half, you drive forward. If you're looking at PWM in like an RC car, you have to have one PWM signal to go forward and a separate PWM signal to go backwards. When you only have 5 channels, and you'd have to use 2 of them for forward and backward and 2 of them for forward backward, you suddenly start running out of motors. But it looks like it will run with the FRC PWM controllers. So if you've got some older style FRC controllers that run on PWM, then it would work for that, and you'd be able to run 5 motors. I think you would still need to power it off of a PDH or PDM, and you could use an old one. I mean, we've got some of the blue ones from 2010 or 2012 that we use on some of our kind of practice spots, I guess you would say, that you could never use in a competition, but they work fine for putting fuses in to run motors. There's also the Hero board. Crossroad Electronics sells a Hero board, but you have to program in C#. If you're a Java programmer, I think it only works with C#. I could be wrong. It might work with Java as well. But if C# is just a different flavor of Java, Microsoft's flavor of Java, and for most people, new programmers can't even really tell the difference because they're so similar. I will say that I have thought about trying to take the Rami image, because it is open source, and trying to figure out how to use it, because a Raspberry Pi has way more pinouts than what the Rami exposes. And so if you could get the raw pinouts on the Raspberry Pi, then you'd be able to control a whole lot more things with PWM and more servos. And you could do digital I/O using SPI or I2C off to your other devices that are running your sounds and your lights. But I have looked at that Rami image that's out on GitHub, and you can do it, but it uses TypeScript as an interface layer between the WPI libraries and the C code that runs the Raspberry Pi. So you have to understand the C, you have to understand TypeScript, you have to understand the WPI lib outputs and how to map them. It's way beyond my current knowledge base, so I didn't go very far with that. So unfortunately, I agree with you that it's really hard to find an alternative control system that doesn't cost you the cost of a RoboRio. It'd be really nice if we had a Raspberry Pi image that we could put on a CAN controller and all of those things. And if there's one out there, I haven't found it yet.
Well, it'll be interesting to see what the new alternative to the Rio is. That's coming out in 2025, isn't it?
Is it already 2025? Because I thought when they reevaluated the RoboRio, wasn't it just last year or 2 years ago? I thought that was a re-up for 5 years.
Oh, maybe. I knew it was coming up for reeval. They were talking about making a controller that was going to be across FTC and FRC.
Does anybody else know? I mean, I know that we've got
I thought it was
mentors on here.
I thought it was 2027
Hmm.
that we were
Okay,
getting at. I'd love to have it earlier.
Yeah, maybe.
The 2027 timeline seems like that probably matches up more with what, because I thought it was a 5-year re-up. So if that was 2 years ago, then that would have made sense.
Okay, yeah. We've got to wait a little bit before that comes out to see if that can bring some of those costs down.
You know, we also have some very smart people at Team 2502 Talon who did all of their robot code this year in Ruby. And so they built their own interop layer between WPI lib and so that they could write code in Ruby. And I almost feel like they wrote their interop layer in JavaScript, which is very similar to TypeScript. It's possible that we might have some friendly teams near not so far away here that would be interested in tackling a project, but or teaching or helping another team tackle that type of project. But I agree. I think it would be, you know, we're using ESP32s to control our LEDs, and it's got 2 dual core processor. It's got 64 gigs of onboard storage and something like 2 gigs of RAM or something crazy. I mean, it's compared to an Arduino, and it runs Arduino code, but it's crazy. And there's $7. It's crazy how cheap they are and how powerful they are. It'd be really nice if we could use some of these microcontrollers like a Raspberry Pi or an ESP32 chipset or something like that. Because I think we could run demo bot type of stuff. I don't think we would be able to do the things that we do for an FRC competition, but it'd be nice to have a smaller platform, but then be able to let our students who know how to write WPI lib code use that knowledge to build robots, or even use them as a training platform, which is what I would be really excited about.
For sure.
Caleb Fineweaver, are you still on the call?
Yep.
Caleb, do you have any thoughts about so Caleb is our programming captain for 2052 Nightcrawler. Do you have any thoughts about building a purpose-built robot that we might use for outreach or as a training bot, maybe a larger training bot?
I mean, I feel like the mini trials bots we use for training, we could like kind of take some of those and isolate mechanisms from them for more training. That's something that we might look into. For demos, I think our t-shirt cannon, right now we're trying to fix it. Kevin's trying to work on the turret or the rotating thing because it broke. I'd be interested in looking into like the hero board and how we can use that more.
One of the things that you had in an earlier slide, which I think is so important, and you went through it really quick, is the size. We take our 2016 bot to almost every demo, pretty much every demo because it's the one robot that'll pretty much go in any vehicle. And I think that that's so important when you're talking about building a robot for outreach is that you need to be able to get it to where you're going to demo it, and you can't require somebody to have a minivan or a trailer to do that. And so I really like the idea of building a purpose-built outreach bot that's small and will basically fit in the back seat of anybody's car.
Well, that has the other advantage of fitting through doors with the bumpers on too.
Yes, right. Yeah. That's another good point is that a lot of the robots we build just aren't they're just not, they're kind of robots that you want to haul around to a library or an elementary school or um, city hall or anything like that where you want to do a demo for somebody, for a group of people. Yeah. Yeah, it is a real big challenge, and for a lot of teams it's just so hard to do demos outside the school because it's hard to get the machine to where you want to demo it.
It's held us back from doing outreach for sure.
Yep. I don't have any other questions. Does anybody else have any questions or any other stuff they want to chat about? Osvia group, are you guys mostly wrapped up here? Do you want to take the conversation a different way?
I have said what I was intending to say. Shrikar, you want to talk about anything specific?
No, not really.
You haven't had any problems trying to get anything to work or things like that?
No, just skill issue.
Okay. How about you, Isaiah?
Not really anything that I haven't talked about. Yeah, no. I have joked about writing an interface with layer with W5 and Haskell, but I don't think I'll go through on that because that sounds terrible.
Yeah, I think there's a lot here. I think this is a really important topic that a lot of teams haven't put the kind of effort and thought into it that you guys have put into it. I think there's a lot of merit to what you guys have gone through here, and I think this is for teams that have the time, because I don't think it's a cost issue so much. I think it's more of a time and effort issue to do this type of thing. But yeah, I would really like to see. I would love to have outreach in a box, and we've talked about this a lot at Nightcrawler. Of we need to have these kits of what type of an outreach are we going to do. Here's the list of things to take. Go and make it easy and walk out the door and have your demo fully understood of what you're going to do and have a list of all the things you're going to take. And we're not at the point where you guys are working towards right now with a robot. We have that with our 2016 robot. But again, not going to go through a door unless you drag it sideways, tip it on its edge and drive it on two wheels kind of through the door. And not super light. It's not something that one person can get in and out of a vehicle. I don't know if if your robot can go in and out of a vehicle with a single person.
Right now, it is built on an old kitbot base, so the answer is no.
Oh, okay.
But because it doesn't have a superstructure to speak of, it's a lot lighter.
Sure.
But right now, it doesn't quite fit through a door. But it would be easy to cut that down, make it narrower. So there are lots of opportunities that I think we have. I think one of the things that it's not a stopping block, it's just a parallel path. When we look at outreaches, having one bot to show a big group is an awesome thing. But more and more, especially if we're trying to reach people who maybe are in the special educational system or just they're really, really interested in the robotics.
Yep.
We want smaller groups. And when we want smaller groups, maybe we want smaller robots. And there's always going to be kind of a balancing act, because we don't feel right now that we can support that by having a bunch of smaller robots and giving that one-on-one attention to a group of people who want to have that kind of hands-on interaction. But we absolutely see that that's what a lot of people want. So it is kind of a stumbling block, because we'd like to be able to do that, and we just really don't think that we can. But for now, having this particular outreach robot has really helped our team learn better how to use the April tags, think through some of the mechanics of programming in a completely different way. They're exploring different controllers for the LEDs. Everything. I mean, we're looking at some LED strips that are all compatible with each other, but their RGB sequence is in a different order.
Oh,
Like,
yeah.
you plug one in and this lights up this way, and you plug another one in, it lights up a different way. You say, well, that's weird. What happened there? So wonderful, wonderful learning opportunities as we try to get this robot up and running to just explore all these things. And because they're trying to create this programming language, in a sense, with the April tags, all of a sudden now they've got to create all of these autonomous subroutines.
Mm-hmm.
And suddenly the PID is huge. You can't really dead reckon very far. So it's a lot of different issues, and it's forcing people to break it down into small bites, which is really exciting to see, because I think it's much more manageable in that way.
Well, I think this has been very good. If we don't have anything else we want to chat about tonight, I'm happy to let this wrap up a little bit early. Does anybody have anything they want to expand on for outreach, or any other topics they just want to bring up as our last call of the year?
No, thank you to Nightcrawlers for hosting all these. This is awesome.
You're welcome. I feel like this has been a really, really great way for a lot of teams to connect in ways they hadn't been able to connect before. And so thank you for everyone here for joining. And thanks a lot. Thank you very much for WildCards for closing off our season with a great presentation. This is, I know a lot of teams try to work on outreach stuff over the summer, so I feel like this was a great way to wrap up our last call of the year. All right, last call. Anybody else want to talk about anything at all before we end this session? All right. Everyone have a great summer. We'll see you in September.
Thank you.
Bye.
Good luck.
See ya.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.